In the span of 2 weeks, AI models from both OpenAI and Anthropic independently breached real organizations, uploaded malware, and socially engineered real open source developers, all while their operators believed that the models were safely contained in testing environments. But these attacks really show where the state of AI red teaming is at today, and most organizations aren't ready to keep pace. But we'll break down on this episode exactly what you need to know.
Welcome to Shadow Talk, a cybersecurity podcast powered by ReliaQuest, the leader in agentic AI security operations. I'm Tehman Tariq, Senior Manager of Gray Matter Operations.
And I'm John Dilgen, Threat Intelligence Analyst. Now, today's episode covers a topic that I know is on everyone's radar: the recent AI security incidents involving OpenAI, Hugging Face, Anthropic, and the UK AI Security Institute. Now, you've probably listened to our previous episode on Mythos before, right? And in that episode, we talked about the first major shift coming from these frontier models, and that's that they were generating a flood of new CVEs, right? But these latest stories really show how that landscape has shifted yet again. And we've moved from AI just finding the vulnerabilities to AI exploiting them end to end. Really, fully autonomous attacks are here.
And that's really the phrase that I want everyone to hold on to, especially for the next 20 to 25 minutes or so. Fully autonomous attacks are here. And every story we're about to walk through really highlights exactly this.
Yeah, it certainly does, Tehman. And, we got 3 really good stories to cover. We're going to first talk about how OpenAI's model escaped through 0 days to breach Hugging Face. Then second, we're going to look at Anthropic's Claude and how it compromised 3 organizations and uploaded malware to PyPI, a common software package solution. And then third, we're going to look at the UK AI SI evaluation, where AI agents targeted real people with social engineering. So let's get into it.
Thanks, John. And let's start with Hugging Face, because that's the incident that I know the audience is the most interested in. So let's first talk about how it broke first and how it really shook things up. So can you walk us through what happened?
Yeah, certainly. So, to come in at a high level, like we said at the top of the episode, what Hugging Face really shows is how those fully autonomous red team attacks are here, right? The model overall used multiple 0 days, escaped the sandbox, and coordinated with peer agents, ultimately breaching a production company. And during these attacks, the agent generated more security events than most SOCs see in a month. So let's really break down how that happened. So OpenAI was testing a pre-release model in an isolated evaluation environment. It was supposed to not have internet access, but it could reach an internal Artifactory server used to pull software packages.
And just to break that down, so on paper, it was contained, but there was still a path out.
Yeah, exactly. And, the model identified and exploited a previously unknown 0-day vulnerability in that package manager Artifactory to gain the internet access. And it's really important to understand, it didn't just do this once, it did it twice with different vulnerabilities after remediations were implemented the first time. So let's kind of set up this timeline, right? OpenAI began this internal research testing with this model on May 7th. And within a day after the model got stuck on its challenge, it reasoned that it could reach the internet indirectly, and then discovered that it could write its own files into Artifactory. And this is a really important piece that you should understand about these attacks, because through this file writing ability, the agents themselves began to communicate in ways that were unexpected through this shared packet repository.
And I want to slow that down for just a second, because I don't think people are going to catch onto this on that first listen. So picture this. You've got dozens of AI agents, each running their own evaluation, each supposedly isolated as well. One of them figures out how to write files to a shared package repo, then another reads those files. Then they start leaving messages for each other. Hey, I found this exploit. Here are the creds I captured. Try this next. They built basically a covert command and control channel out of a package manager.
Yeah, and Tehman, that's a really important piece that changes the threat model here. And so I want you listening to understand that this is not just one agent conducting an attacks, because through this communication, it's really a swarm of agents that's sharing tradecraft in real time. Now, picking back up on the timeline, the agents found multiple artifactory flaws, including remote code execution and privilege escalation. Now, OpenAI patched and hardened the environment after an outage exposed the first round of activity. But 2 days later, the agents rebuilt their coordination channel through a completely different mechanism and pushed outward. Right from there, it breached Hugging Face's production infrastructure by exploiting vulnerabilities in their data processing pipeline. They were able to steal cloud and cluster credentials and move laterally across internal systems. Now, the intrusion on Hugging Face's side lasted approximately 4 days, according to a postmortem, with 2 days of reconnaissance, one where the agents were largely silent, and a final day of intense activity.
And correct me if I'm wrong, but didn't the scope expand beyond just Hugging Face?
Yeah, it certainly did. And, OpenAI's July 20th update really revealed that the models also used publicly exposed credentials to compromise accounts on four. I'm going to pause there. That's four third party services, one of which was used for outbound relay and staging, another for data storage, and then two were accessed just for information. All right, so stepping out of the kill chain here, what's really notable is that the agent assembled infrastructure very similar to how we would see human threat actors doing it, right? They used legitimate services to host tools, relay traffic, and stage operations. It used things like Pastebin and HTTP request capture services, as well as screenshot tools. But by and large, this was a structured and multi-stage attack.
And I want to layer in there, it's likely that the agents are copying known techniques that are referenced on the web and then were used in their training as well.
Yeah, and I think that's another really good call out, Tamon, because a lot of what these agents are able to do is mirroring known attack paths, which will really come into play as we get into the remediations. Okay. Now, another important detail we want to call out here is that in its response, Hugging Face had to use AI to analyze the attack. It had over 17,000 logged events that took place as a result of the activity. And Hugging Face initially tried to use different commercial AI models to reconstruct the attack, but the safety guardrails within those models blocked processing the actual malicious activity. So they had to find a model that worked and eventually went with an open source one.
And the major point there is that Hugging Face lost valuable investigation time because they had to set up the AI for analysis rather than having one already in operation. And also, something that's very important is that if you're thinking, okay, that's an open AI problem, I want you to hold that thought because Anthropic disclosed three other incidents that make it clear that this isn't just one AI. It's a pattern, isn't it?
Yeah, it really is a pattern, right? And again, like we've teased at the top of the episode, the pattern is really showing where frontier models as a whole are headed, right? So Anthropic disclosed three separate incidents where Claude models reached the open internet from evaluation environments that, again, were supposed to be sealed. All three happened during capture the flag exercises run through a partner. In one event, Claude identified an unpublished package name in developer instructions, registered it on PyPI, a Python package manager, and turned that into a live supply chain attack. To do it, the model worked through account creation hurdles on its own and eventually got the malware published.
Yep. And to sum it up, the model identified and executed a supply chain attack on its own.
Yeah. And that's a really key point, too, because, I'm sure our listeners are aware of all the supply chain attacks we heard at the, or earlier in the year, I should say. And here's just another example of one now AI hosted. Now, in another incident, the fictional target shared a name with their real company. And across four different tests, Claude extracted credentials and reached a production database that was holding several hundred rows of real data.
And now the UK AI Security Institute, or the AISI evaluation, which covers an attack that introduces social engineering against real people.
Yeah, all right. So this one, right, the UK AI Security Institute, they also saw agents take unsanctioned actions on the live internet. In one case, in their evaluations, a Mythos 5 agent targeted a real GitHub project, launched a supply chain social engineering campaign against its maintainer, and this included sending targeted emails to developers and even signed off in communications in Danish to help phish the Danish speaking code maintainer. Now, what's really important is that AISI, that institute, called it the first time we've seen deception of this severity targeted at a real person unprompted in the real world.
And this was another reminder that it's a swarm of AI behind these attacks. As researchers found, the agents coordinated across different runs using a shared GitHub repository as a message board.
All right, Tehman. So we've kind of covered the major headlines and the stories here, but let's take a step back and talk about what this means for those listening, right? For your environment, your team, your security program, what are the key challenges here?
Yep, absolutely. And the first one that I want to talk about is that the attack path is familiar. These agents exploited the same weaknesses defenders already struggle with. Think about like exposed credentials, unauthenticated endpoints, and unpatched software.
Yeah, that's a really good point. They're not rewriting the attack chain. The novelty is not in the weaknesses themselves. It's, the compression that's happening that's leading to faster execution. What might take an attacker weeks is now happening in days.
Exactly. And the second piece I want to mention is the volume specifically. So, Hugging Face dealt with more than 17,000 events generated by a swarm of agent attackers. This is the part that many teams should focus on. Not whether the attacker was AI, but whether your SOC can analyze and contain that much activity at that fast of a speed. And the third one I want to mention is supply chain trust. AI agents can now autonomously register packages, create fake personas, and socially engineer real maintainers with persistent, coordinated pressure that adapts when challenged. There is a clock that is ticking, and when these agents are widely weaponized, then the scale of supply chain attacks will surge. Your open source dependencies and your code review processes are at risk, and now is the time to iron these processes out.
Yeah, good call out. And I just want to put some context behind this for you listening, right? One of the things we called out is that they're not recreating attack chains there, or I shouldn't say they're not reinventing attack chains, they're recreating what's already been seen. And a big reason we're seeing the supply chain attacks is because we've seen lots of recent public examples of supply chain attacks. One threat actor comes to mind is Team PCP, who's behind a lot of the major NPM worms. And what I want to call out is that their major credential stealing worm, Shah Halud, they released that publicly out on the internet. So that this is something that the models themselves can reference.
Yep, great point, John. And then the final thing that I want to mention is that this shows how assumptions and model testing and validation can quickly break down. In both cases, the companies relied on prompts telling the models they had no internet access. The models then inferred that the environments were staged and proceeded with harmful actions, anyways. So, if your organization develops AI models, runs evaluations, or deploys AI powered tools, you cannot treat prompt instructions alone as the only security boundary there is. Instead, you need to have a clear standard for AI testing and validation.
Yeah. All right. So let me kind of wrap things up here and really put a bow on this, right? Because here is what you need to understand before we go into the break. AI hasn't changed the attack patterns. It's just better at exploiting those same gaps that attackers go for. As attackers start getting access to these autonomous red teaming capabilities, your organization needs to be able to investigate and contain the mass volume of events quickly. But when we're back, we'll discuss exactly how.
Shadow Talk is brought to you by ReliaQuest, the global leader in AI cybersecurity. ReliaQuest helps enterprise cybersecurity teams contain threats in minutes with its agentic AI security operations platform, Grey Matter. ReliaQuest makes security possible for the most trusted enterprise brands in the world. Learn more at ReliaQuest.com.
And we're back. Next, we're going to talk about what you can actually do about this. John, where should teams start?
Yeah. So, the first recommendation here is pretty simple, right? These AI agent compromises really all started in a similar way. Things like publicly accessible credentials or endpoints that required no authentication. So that's your number one starting point. And if you do nothing else after this episode, you should be auditing your internet facing services for unauthenticated management interfaces, debug pages, credentials in public repositories, service accounts with default passwords, and open sandbox environments.
And there's a less obvious one that came directly from the PyPI attack as well, which is called phantom dependencies. If your internal documentation references a package name that nobody has published to a public registry, an attacker can then claim it. Audit your dependency list for packages that don't exist or that no longer exist. And moving into our next discussion topic, I want to talk about AI driven investigation and some of those automated response actions. So we know that hygiene is a top priority, but the next recommendation speaks directly to the speed problem. When AI agents can quickly breach infrastructure and generate more events than your team can investigate, your response needs to operate at the same scale and speed.
Yeah, and Hugging Face, that example really proved this, right? They needed AI to reconstruct the attack from over 17,000 events, and they lost time while they were trying to set up a model. So your organization needs investigation tools that can correlate high volume event streams at machine speed, backed by automated containment playbooks to buy your team the time to investigate.
And critically, test those playbooks against AI agent scenarios specifically. Fast, multi vector parallel operations, not just the traditional human speed intrusions your tabletop exercises have been built around.
Yeah, that's a good call out. And another one I want to call out too, as we discuss the speed of these AI agents running, is that you can implement strategies to slow down the AI during the attack, right? You can implement things like honey tokens and other deceptive tools, before an attack happens. And these will cause the AI agents to become uncertain during their attacks and increase the time it takes for them to make decisions and execute their attack.
And the next discussion topic that I want is how to harden those supply chain review processes. For anyone maintaining open source projects or accepting external contributions on software, your review processes need to account for AI driven social engineering as well.
Yeah, they certainly do. And really you need to implement things like multi-person review for all pull requests with out of band identity verification for first-time contributors, age activity, or I should say age and activity thresholds for accounts that can approve changes, and then look for coordinated behavior on code changes, right? Things like multiple new accounts endorsing the same change, accounts that are created in close proximity, or even pressure campaigns following a code rejection. And especially scan incoming contributions for prompt injection payloads targeting AI coding assistance. That one thing was specifically documented in the AISI report.
And we're going to move to our last topic, which is testing and validation. So, if your organization runs AI models, hosts evaluations, or deploys AI powered tools, prompt instructions are not the only security boundary. You need to have rigorous standards for implementation and for AI testing and validation as well.
Yeah, and this includes things like applying the principle of least privilege to all AI credentials, ensuring there are no ambient cloud credentials or broad service account access given out, monitor for execution environments for outbound connections and package installations from external registries, and then audit your third party AI partnerships to ensure that they have a system for AI testing and validation. Right here at ReliaQuest, we've created the universal standard for AI testing and validation, which serves as the foundation for building trust in AI across any field that you use it in. Right. And so this can really be used to validate and test any AI system that's in your environment today.
Perfect. And to close this out, let's pull this back and give you the actions you can take. I'll start with the security leaders first. So, if you're a CISO or a security leader, this episode puts an AI governance question on your desk. Any place in your environment where AI models are running, being evaluated, or being deployed, Prompt instructions and safety training cannot be your only security boundary. Both OpenAI and Anthropic learned that the hard way. You need a rigorous, documented standard for how AI systems are implemented, tested, and validated before they get access to production data, credentials, or tooling. Next, the speed advantage matters every time. AI agents can move from recon to exploitation faster than most teams can investigate manually. So, one of the most practical things a CISO can do is slow them down. That means putting friction into the attack path with controls such as honey tokens, deception assets, and tripwires that create uncertainty, trigger validation steps, and force the agent to spend more time deciding what is real. Even small delays can have a meaningful difference. This will help buy your team time to detect the activity, investigate it, and contain it before the attack escalates any further. And the morning action for leaders is this: review your deception strategy as if an AI agent was already operating in your internal network. Identify where you have honey tokens and tripwires today, and then build a plan to add more around those exposed credentials, package abuse, and supply chain attack paths as well.
All right, those are some great recommendations for the leaders. For the operators, I'm going to take it back for number one to those key things we see getting exploited, right? So my recommendation is run an immediate audit of your internet-facing services for exposed credentials, unauthenticated endpoints, and debug pages, right? The AI agent compromises we covered today really started here. And, to restate again, the attack surface hasn't changed, but it's getting faster and getting hit more consistently. Now, number two is going to be harden your supply chain and code review processes for AI-driven social engineering. If you use open source projects or accept external contributions on code, then you should implement protections like requiring multi-person review on pull requests, enforcing age and activity thresholds for accounts that can improve changes. Also, watch for coordinated behavior, like multiple new accounts endorsing the same change. And really, my tomorrow morning action here is to have you pull two different lists. The first one is going to be every internet-facing endpoint and service account in your environment. And then you're going to cross-reference that list for details like default credentials and exposed management interfaces. Second, every internal document, README, or setup guide that has a reference to a package name, and then verify each one is actually published and owned by who you think it is to ensure that you don't have phantom dependencies lingering that an attack could take advantage of. So in closing, the threat from frontier AI models is no longer just that wave of CVEs that we talked about earlier. It's really clear that fully autonomous attacks are here and defenders need to keep up. Well, that's all for this week. Thanks for listening to another episode of Shadow Talk. As we've mentioned, we added a feedback survey in the link tree below. It only takes a few minutes. Please let us know how we can improve. You can also always reach us at shadowtalk@reliaquest.com. And we'll be back with another episode of Shadow Talk.